Hello everyone, welcome to JCE Connect. In today's session, we are going to discuss about the viscosity, that is the definition of viscosity, velocity gradient and coefficient of viscosity, and types of. So first let us define what is viscosity. So look at this picture. In these pictures we have taken three types of fluids, and in the first bottle we have taken the paint, second bottle the uh, oil, and the third one is honey. So by looking at this picture, so we can answer for this question, that is what is viscosity. So imagine a bottle is made whole and allowing the liquid to drain. If I pour a paint, the first bottle here, in this first bottle, this one is a paint and this is oil and this is honey. So in this first bottle, if I pour, then I will find that the bottle drains very slowly here. In this case, the bottle drains very slowly. And if honey is pouring, then again compared to the paint, so again this will be draining faster than the paint. So if you compare third one, oil, compared to paint and honey, this is draining more fast. So this is because the paint will be having less viscosity. So the paint will be having high viscosity as compared to the honey. And if you compare the honey with oil, honey will be having again more viscosity than oil, and the oil will be having less viscosity. So hence it drains much more quickly compared to other types of uh, liquids. So hence the viscosity is a measure of fluid's resistance to flow. You can look at this picture here. The one that is in this uh, water is pouring in this container, and here a paint is pouring. This is paint and this is water. See, look at this, how this container is uh, filling faster than the paint, because the paint having high viscosity than the water. Hence we can say that viscosity is a measure of fluid's resistance to flow, and also it describes the internal friction. So as I said, viscosity is a measure of fluid's resistance to flow, and it describes the internal friction of moving fluid. A fluid with larger viscosity resists motion because its molecular makeup gives it a lot of internal friction. A fluid with low viscosity flows easily because its molecular makeup results in a very little friction when it is in motion. So you can say the viscosity denotes the opposition to flow, and the reciprocal of the viscosity is called the fluidity. The reciprocal of viscosity is called the fluidity, that is a measure of the ease of flow. And even the gases also have a viscosity, although it is a little harder to notice it in ordinary circumstances. So why should you measure the viscosity? So there is always a question why we need a viscosity. So what is the use of it? So the use of viscosity is gathering a viscosity data on a material gives manufacturers the ability to predict how the material will behave in the real world. For example, uh, if you take a toothpaste, real toothpaste, uh, if the toothpaste does not have, see, look at this picture, if the toothpaste does not have the correct viscosity, it will either be too difficult to pump out pump out the paste from the tube, or too much of it will be pumped out. So look at this picture here. So we can uh, say this is more viscous. If the viscosity of the paste is more, so we need to apply more force to take it out. If it is less viscous, it easily. Again, the viscosity is more important to measure viscosity. It's not too high or too low to ensure a quality, also consistent product. Third, also knowing the viscosity of the material affects how production and transportation processes are designed. The viscosity measurement for different fluid is very much important in food processing industries, pharmaceuticals, cosmetic and petrochemical industries. It also extremely needed during design and hydrodynamic system. So again, the viscosity, how the viscous forces exist between the fluid layers, as we have defined the viscosity as uh, measure of a fluid's resistance to flow. How exactly the resistance of a fluid will takes place, and how the viscous forces exist between the layers, we'll see in this section. So here, uh, when a liquid flows on a horizontal surface, so here we have taken this AB as a horizontal surface or horizontal plane. When the liquid starts flowing on a horizontal surface, the velocities of different layers of liquid will be different. In the case of streamline flow, means the continuous flow of liquid, the layer of a liquid, uh, the layer of a liquid in contact with the surface remains stationary. So at this position, the layer of a liquid in contact with the surface remains stationary. The velocity of any layer, if you go in the upward direction, the velocity of any layer parallel to the surface increases with distance from the fixed surface. In other words, there is a relative motion between the successive layers of the liquid. So in the absence of an external force to maintain this relative motion, the faster layer tends to accelerate the slower one, and the slower one retards the faster one. So thus, in case of a liquid having a relative motion between its layers, internal forces are developed. So between internal forces are developed between the layers, and these retarding internal forces are developed which retard the relative motion. So these retarding forces are called as viscous forces. So here between the layers, internal forces will be developing which retard the relative motion between the layers, and these retarding forces are called as viscous forces. Hence, the property of a liquid by virtue of which it opposes the relative motion between its layers is called viscosity. So again, uh, generally thin liquids like alcohol, spirit and water are less viscous, and thick liquids like glycerine, castor oil, coal tar are called as uh, thick liquids and are more viscous in nature. So just look at this picture here. So high viscosity liquid means the less flow. We can get the lesser flow mobility or lesser fluidity, we can say. Sorry, lesser mobility means high viscosity fluid. Here low viscosity means more flow, more fluidity. Here less fluidity, here more fluidity. Okay. So let us consider one more example here. Before that, if the velocity of layer is same, then the relative motion is zero and the liquid is said to be non-viscous. Means for the non-viscous liquid, there won't be any relative motion exist between the layers, means all the layers will move with the same velocity, all will be having same velocities. Okay, all will be having same velocity. If you take the relative velocity between the two layers, so the relative velocity will be zero, hence those liquids are called as non-viscous liquids. Let us consider one more example to understand the viscosity. When two beakers, one containing oil and the other alcohol, are tilted from side to side, consider the two beakers and one containing oil and other alcohol are tilted from side to side, lesser mobility is observed in oil than the alcohol, because oil offers more resistance to relative motion and is said to be more viscous than the alcohol. Hence, alcohol, spirit, water are taken as a less viscous liquids, whereas glycerine, castor oil and coal tar are taken as thick liquids, and they are also called as a more viscous liquid. Even greater viscosity favors streamline flow. So here look at this one. This is having a high viscosity. So greater viscosity favors a streamlined flow, whereas lower viscosity favors the turbulent motion. The viscosity of a liquid decreases rapidly with increase of temperature, while that of gases increases. And the viscous forces do not operate as long as the liquid is at rest condition. Means the viscous forces will not be uh, come into picture as long as the fluid is at rest condition. So viscous forces will come into picture only when the fluid starts moving. Thus viscous forces is similar to a friction between, means these viscous forces whatever the existing between the layers is similar to a friction between two surfaces in relative motion, and viscosity is sometimes called as internal friction. Whatever the viscosity existing between the layers, that is also called as a internal friction. So the fluid's internal friction is nothing but viscosity that exists between the layers. So again, let us one more example consider. When a water in a beaker is stirred, if you take a water in this beaker and if it is stirred, it is brought to rest after some time by internal friction between the layers of water. So if you stir the water in a beaker and if you wait for some times, so it is brought to rest after some time by the internal friction between the layers of water. So this is what the definition of viscosity. Okay, I hope you understood this one. So means whenever a fluid starts flowing on horizontal surface, so there will be a relative motion between the fluid layers. The relative motion between the fluid layers. Here, the faster layer tends to accelerate the slower one, and the slower layer tends to decelerate the faster layer. Hence, there is a relative motion exists between the fluid layers. That relative motion is because of the viscous forces existing between the layers. So, thus, the property of a liquid by virtue of which it opposes the relative motion between its layers is called viscosity. Velocity gradient and coefficient of viscosity. So, in case of a streamlined flow of a liquid over a horizontal surface, the velocity of a layer increases with distance from the fixed surface. So when a liquid flows on a horizontal surface here, so this is a horizontal surface of AB. So when the liquid flows on this surface, the velocities of different layers. So let us take the layer A, B, C like this. The velocities of different layers of the liquid will be different. So when a force or the pressure force is being applied, that is pressure force P is equal to force by area. When a force is being applied per unit area, the liquid starts flowing. So on this horizontal surface AB, so the very first layer of the liquid which is flowing over this horizontal surface, So we'll be having a zero velocity because it is adhering to the surface. That is the very first layer. Then the second layer of that liquid will be having some velocity. So let us take this velocity is zero because it is in contact with the horizontal plane AB, where the horizontal plane AB is a stationary, and a second layer will be having a certain velocity, say V1, third will be having a V2 and V3, and it goes on. Okay, as the distance increases from the horizontal plane, the velocity get increases. So we can introduce a term called velocity gradient. Means suppose if we take a length of or height L, for a height L, if we consider the velocity difference between this layer and this layer as a V, we take the velocity difference. So for a L height, for L distance, the velocity difference between the two layers is V, and for one the velocity difference will be V by L. So this is what we call as a velocity gradient. Velocity gradient. Then what does it mean? Velocity gradient. So velocity gradient means velocity changing per unit height or per unit distance is known as velocity gradient. Or in other word, the rate of change of velocity with a distance y measured normal to the direction of flow is called velocity gradient. So if we take this as a y-axis and this as a x-axis, so the rate of change of velocity with a distance y measured normal to the direction of flow is called as velocity gradient. So from this we can say that there is a relative motion between a fluid layer exists, so which opposes the motion of the fluid, and hence that force whatever opposing the motion of the fluid is called as a viscous drag, which is acting opposite to the direction of flow. Means when there is a relative motion, between the two layers, so say layer, this is a layer 1 and layer 2, when there is a relative motion exists between these two layers of flowing liquid, a force of reaction develops to oppose this applied force, which is creating a velocity. This is called a viscous drag, and that this direction of viscous drag is always tangential to the layer. Thus the property of a fluid to develop this drag is called as viscosity. So as I said, for a unit height or for a unit length, the velocity difference is V. Means here we are applying a pressure force, that is pressure is equal to force per unit area, that is applied force. For the applied force, so the layers of the fluids are moving very fast, so that is the velocity is maximum for the upper layer. So if we take the difference of these two, or we can take the relative velocity between the two layers, then there is a velocity gradient exist. So for a unit length, that is for a length L, the velocity difference is V. For a unit length, the velocity difference will be V by L, that is called velocity gradient. So we can, from this we can write the force per unit length is directly proportional to the velocity gradient. The force per unit length, whatever the force applying per unit area, which directly relates to the velocity gradient. So higher the force applied, higher will be the velocity gradient. So lesser the force applied, lesser will be the velocity gradient. So if we replace this proportionality constant, we can write from this, we can write force by area is equal to mu, a term introduced, that is mu into V by L, where mu is known as modulus of viscosity. Mu is known as modulus of viscosity, or it is also called as coefficient of viscosity. Coefficient of viscosity. So as I explained earlier, when there is a relative motion between the two layers of a flowing fluid or flowing liquid, a force of reaction develops to oppose this applied force, means this applied force, which is creating a velocity. This is called viscous drag, and this direction of viscous drag is always tangential to the layer. Thus the property of a fluid to develop this drag is called viscosity. So hence, as I mentioned, modulus of viscosity or coefficient of viscosity. So what does it mean? So coefficient of viscosity of a liquid is equal to the force applied per unit area on the liquid, which create a velocity gradient of 1 per second or 1 unit. Means, so if we write mu equal to force applied, mu equal to force applied means if we make area of 1 meter square or 1 unit area and velocity gradient of 1 unit, if we make 1 unit, so then this coefficient of viscosity will be equal to the force applied. Hence we can define this coefficient of viscosity as the coefficient of viscosity of liquid is equal to the force applied per unit area on the liquid, which create a velocity gradient of 1 per second or 1 unit, because the unit of velocity gradient is per second. So velocity gradient V by L. So if we rate a velocity meter per second and length is meter, meter get cancels, so we get per second. Hence the coefficient of viscosity of a liquid is equal to the force applied per unit area on the liquid, which create a velocity gradient of 1 per second or 1 unit. So this is about velocity gradient and coefficient of viscosity. So here we can derive the equation for the viscosity. So here a viscosity is defined as the property of a fluid which offers a resistance to the movement of one layer of a fluid over another adjacent layer of fluid. So when two layers of a fluid, a distance dy, here we are considering two layers of a fluid, a distance dy apart, move one over the other at different velocities, say u and u plus du, as shown in this figure. The viscosity together with the relative velocity causes a shear stress acting between the fluid layers. Now, in this flow of liquid, layers of liquids are flowing, so with velocity u and u plus du. So here the top layer causes a shear stress on the adjacent lower layer, while the lower layer causes a shear stress on the adjacent top layer. So this shear stress is proportional to the rate of change of velocity with respect to y. So and hence it is denoted by a symbol called tau. It is denoted by a symbol called tau. So mathematically we can write, so this tau is directly proportional to the rate of change of velocity with respect to y. So if we replace this proportionality constant, we get mu, that is tau equal to mu into du by dy, say equation number 1.2. So where mu is called the constant of proportionality and is known as coefficient of dynamic viscosity or only a viscosity, and du by dy represents the rate of shear strain or rate of shear deformation or velocity gradient. So as we defined previously, velocity gradient means the velocity changing per unit height or per unit distance is known as velocity gradient. So from equation number 1.2 we can write mu equal to tau divided by du by dy. Hence the viscosity is also defined as the shear stress required to produce unit rate of shear strain. So this is called viscosity. Okay. So mu is equal to tau divided by du by dy. Next, the units of viscosity. So units of viscosity can be written. So in MKS system, MKS unit of viscosity can be written kgf second per meter square, because the viscosity is what? Stress, that is tau divided by du by dy. Sorry, this is, so mu equal to tau into du by dy. Mu equal to tau divided by du by dy. So here tau is what? Force by area divided by this, we can write velocity by y. So we can write force in MK system kg divided by area square. So we can write this velocity gradient unit is per second. So kg second per meter square will be the unit of viscosity. In CGS system, dyne second per centimeter square, and in SI system, Newton second per meter square. And the unit of viscosity in CGS is also called as a poise, which is equal to 1 dyne second per centimeter square. So 1 poise equal to 1 by 10 Newton second per. So these are the units of viscosity, that is dynamic viscosity unit.